All right, so in 1.2 we talked about functions, or we started to talk about functions, beginning just evaluating a function at an indicated value. So if it said f of x, f of -2, what are we supposed to do with that? Good. So everywhere there's an x in my f of x, I'm going to take it and replace it with the -2. So I'd get 2 times -2 squared plus the -2 minus 1. Remember, when you plug it in, you're plugging it in parentheses. So that becomes -2 times -2, which is a positive 4. 2 times 4 minus 2 minus 1 is 8 minus 2 minus 1, which is 5. Raise your hand if you got it right. Good. Okay, then for 2, we're now plugging in a variable. So it's not going to go completely way down to a number. Okay, but I can at least simplify it. So I'd get 2 -a squared minus a minus 1. And I want to simplify that. So 2a squared minus a minus 1. Yep.
Could you factor it in?
You don't need to factor it. So it's actually more simplified in the way that in the form that it's in. Sometimes you can factor that, sometimes you can't. So when you're writing your answer, you just want to leave it expanded. Yeah. Unless it says to factor or to solve it, right? Then we plug it in. Okay, and then the last one, now I've got an expression to plug in. So I'm going to take that x plus 2, so it'd be x plus 1. X plus 1 squared plus x plus 1 minus 1. I'm going to expand and FOIL this. So when I expand x plus 1 times x plus 1, the 2 goes on the outside. I'd get x squared plus 2x plus 1 plus x plus 1 minus 1. Then the 2 gets distributed. 2x squared plus 4x plus 2 plus x plus 1 minus 1. And then go through and simplify as much as you can. So a plus 1 and a minus 1 are going to cancel out. 2x squared is the only term squared, so it stays as it is. But the 4x gets combined with the x. I get 5x and then plus 2. So typically you want to put your answers in order of decreasing degrees. So highest exponent down to none. Questions on any of those? Everybody good on that? Yeah? All right, then we got to domain. So remember that there were 3 basic things we need to look for domain. So domain is all real numbers. Domain is what we can plug in for x, right? So it's all real numbers except for 3 cases. The first one is if there's a variable in the bottom, right? Because if we divide by 0, what happens? It's undefined. So I would set whatever's in the bottom not equal to 0, and that gives me the set of numbers that can get plugged in for x, which is what you're trying to find. The second one was if there's a root, any root, right? Whether it's in the top or if it's being added or subtracted from something, okay? And the roots, I can't square root a negative number, right? So I'm saying that whatever's under the root has to be greater than or equal to 0. And then the third was the combination of the 2. If that root is now in the bottom, it can't be negative and it can't be 0, which means I set it greater than 0, right? Any questions on what we're looking for? Okay, so in 4, which case do I have? Variable in the bottom. So I'm going to say that this cannot equal 0. So 3x cannot equal -1, and x cannot equal -1/3. So this is one way to write your answer. The other is interval notation, and interval notation, which we're going to need for tomorrow. So if you keep in mind that if you were in Algebra 2 Honors, you should have seen interval notation. Interval notation gets brought in with pre-calculus, and the Algebra 2 Honors book has pre-calculus in it. So you should have already seen interval notation. Algebra 2, you may have never seen it before yesterday, so don't freak out yet. But do realize that you do need it for tomorrow's section. That's why I started with it yesterday. So this means all the numbers except for -1/3, which means from -infinity to -1/3, and a parentheses means don't include that number. But I do have to include everything after -1/3, so I get a union, and then -1/3 to positive infinity. So a non-equals to in inequality or in interval notation looks like that. -infinity up to the number, union that number to positive infinity, but a parentheses goes on both of those. Questions on that one? Okay, then in 5, I've got a square root in the top, which means my first restriction comes from setting this greater than or equal to 0. So x has to be greater than or equal to -1. And there's a restriction in the bottom, which would be that x minus 3 has to be greater than 0. So x has to be greater than 3. Now I have to use a domain in which it works for both, which means if a number doesn't work for one, it can't work for the other, okay? The easiest way, in my opinion, to do this is kind of give yourself a number line. Put your numbers in order, so -1 would be smaller than 3. And then the greater than or equals to would be a solid dot or a bracket, which means that if it was just the numerator, my set of numbers would look like that. It would start at -1 and it would go to positive infinity. The second set of numbers starts at 3 but doesn't include 3, which means a parentheses or an open dot. And it has to be greater than 3, which points to the right. Now, if it rules it out for one, it rules it out for both, which means I can only take where it overlaps, which is from 3 to positive infinity. So it's going to be the narrowest set. If by chance we said -1 to positive infinity, think about what happens in between -1 and 3. So if I plugged in, let's say, something easy like 0, right? 0 falls in between them. Can I plug 0 into my numerator and get the square root of 1? Is there an answer there? Yep, works there. How about if I plug 0 into the bottom? I end up with what? An imaginary number, okay? So if it doesn't work for one, you can't include it in your overall domain. Does that make sense? So I'm looking for where these overlap. Questions on any of the warm-up? Okay, so we're going to finish 1.2 today. Yesterday you did like all this stuff about domain. You did all this stuff about evaluating the functions, okay? We're going to difference quotient. Okay, so this is most likely, unless you've seen it before, this is brand new to everybody. This is like a level playing field, right? And it looks a heck of a lot scarier than it is. Okay, are these work? Yes. Are they difficult? No. Once you figure out what it is, it's super easy. So if it says to find the difference quotient, this is your equation or formula for the difference quotient. You have to find f of x plus h, and then subtract from it your original f of x, which you'll be given what f of x is, and then put it over h and simplify it as much as you can. So we're going to break this down into parts to make this easy. First, we're going to find f of x plus h. Then we're going to take from that, subtract the f of x from it, and then the last thing is just divide it by h and simplify it, okay? So again, these take work, but you just got to be really careful with your signs and stuff. But that's something you need to memorize. What is the difference quotient, which is f of x plus h minus f of x over h. And then this bottom just says that x cannot equal 0. H. Why do you think it says that? It's in the denominator, right? That is the domain for this function already. Does that make sense? Okay, so it's a restriction or a domain on the function because there's a variable in the denominator. Pick up where that left off, which is the difference quotient. Oh, I skipped a step. All right, so this is the way we're going to break it apart, okay? The instructions will say find the difference quotient. So this time it gives it to you, but it doesn't always give it to you. It just could say find the difference quotient. You need to know what that is, okay? But it does have to give you what f of x is. So the first thing we're doing is just finding f of x plus h. So think about evaluating the function. Go back to what we did in the warm-up. If I had f of x plus h, what do I do with that? Plug the x plus h into each of the x values of my f of x. So f of x plus h would equal, in this case, x plus h squared minus 2 times x plus h minus 5. So I've taken the x plus h and I've plugged it in wherever there's an x on the f of x. With me so far? Yeah? Okay. Now we're going to go through and expand and FOIL this out. Distribute the 2. Okay, we're going to FOIL this out. So I get x squared plus xh plus xh plus h squared minus 2x minus 2h minus 5. And then I have two xh's. That's why you got to be consistent with how the order you write it. As hx or xh doesn't matter as long as you're consistent. I want to combine those together. So I get x squared plus 2xh plus, God bless you, h squared minus 2x minus 2h minus 5. That whole thing is your f of x plus h. So that is this part of my function. God bless you. Questions so far? So all we did was find f of x plus h. So from that, I have to subtract f of x. What is f of x? This whole thing, right? So now I'm going to do this part. So I'm going to take my f of x plus h. I'm going to try to color code it so it makes sense. X squared plus 2xh plus h squared minus 2x minus 2h minus 5. And I'm going to subtract from it my f of x, which is x squared minus 2x minus 5. This is the biggest mistake made. Make sure this minus goes to all three terms, okay? It changes everything after it. So this is going to become x squared plus 2xh plus h squared minus 2x minus 2h minus 5 minus x squared plus 2x plus 5. Now I'm going to simplify it. So there's a negative 2x and a positive 2x. There's a positive x squared and a negative x squared. And there's a negative 5 and a positive 5. Still with me? And what's the last part of the difference quotient? It goes over h. So I'm going to rewrite this in simplified form. 2xh plus h squared minus 2h all over h. Can that be simplified? Is there an h in each of the terms in the numerator? Yep. So I'd get 2x plus h minus 2.
How are you going to simplify if there's like a plus or minus?
As long as you're simplifying from every single term in the top. So if one of those terms didn't have an h, I'd leave it. But because every single term can be reduced by the same thing, you could do it. Yeah. Questions so far? So again, it's tedious. It's really easy to make a mistake, especially with positive and negative, so be really careful. But you know how to evaluate a function. You know how to take x plus h and plug it into something. Okay? You know how to subtract and combine like terms. So the steps here are not complicated. It's just that the overall process takes a little bit of time. So we did this all in one slide, which means you can skip this. Like I separated out on your slides, but we did it all together, so you can skip that. And I want you to change example 5 so that it just says find the difference quotient. So that is now, and actually added 2 onto the front of this. So it should be 2x squared minus 3x plus 1. Make those changes and then go ahead and see if you could do it. So you're finding the difference quotient using f of x is 2x squared minus 3x plus 1. All right, so again, difference quotient is f of x plus h minus f of x over h. So the first thing I'm going to find is the f of x plus h. I'm going to take this and I'm going to plug it into each of the x's. So 2 times x plus h squared minus 3 times x plus h plus 1. We're going to do this part a lot. So if you want to memorize that, which is x squared plus 2xh plus h squared. Okay, it'll save you some time. Distribute the -3, so -3 minus 3h, and then plus 1. Distribute the 2 in, 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. See if you can combining like terms. So far, no. So this is my f of x plus h. We good so far? Everybody get it right so far? Yep. Any questions if you didn't? Okay, so that's the first part, right? Then I'm going to take from that and I'm going to subtract my f of x. So I'm going to take my 2x squared plus 4xh plus 2h squared minus 3h minus, sorry, 3h plus 1. Subtract from it my f of x. So minus, I'm going to go ahead and distribute it right now, but make sure you're careful. 2x squared plus 3x minus 1. So every sign thereafter should get distributed. And then I'm going to put all of this over h. Now go through and cancel out what you can. So I have a positive 2x squared and a negative 2x squared, a negative 3x, a positive 3x, a positive 1, a negative 1. I end up with 4xh plus 2h squared minus 3h all over h. And then there's an h in each term. So this is 4x plus 2h minus 3. Questions on any of it? Raise your hand if you got it right. All the way right. Good, good, good. If you didn't, be careful, okay? It's probably like a sign here or there. You're going to make sure that you know the difference quotient formula and then make sure that you're careful on your signs. All right, so the good news is tonight's homework is only 2 questions, okay? It's on WebAssign already if you want to open it up. I said it at the beginning, but remember, if you're having a problem, like if it kicks you out or whatever it is, take a screenshot. You're going to have to do this work somewhere anyways, right? We're not doing this stuff in our head. So take a screenshot of the 2 problems that you're given. If you want to work in Notability, pull it into Notability. Do the work right next to it in Notability. If you want to do it on a piece of paper, do it on a piece of paper. Just make sure you have your problems written out. And then go back and submit it. Number 1 simplifies. They're both like write-in answers. There's not multiple choice. So number 1 simplifies. It should be not tricky. Number 2, it depends on how you write it, whether or not it's going to mark it right or wrong. Okay? So don't freak out if you get a 50, because I know that this is how this is set up tonight. Okay? I'll look at your work. If your work is there, then you're fine. Okay? But this is for you to be able to check your answer. So I said it, as soon as you submit it, it'll allow you to check your right or wrong answers. So then look at your work and then go back and see if it's just the order that's why you got it wrong, and then don't freak out. There's the opportunity to get extra practice problems on this stuff, so if you need it, do it. If by chance it's short, it cuts you out when you're working, then submit the screenshot of the problems with your homework as your homework assignment. We good? Yes? Okay.